In this example, we will be evaluating the square root of 89 to the nearest tenth place decimal approximation. To do this, we want to look for perfect squares nearby to 89. An example of this is 9 squared. 9 squared is 81. We can also look at 10 squared, which is 100. And we can see that 89 lies between 81 and 100. So we can use this information to write the following inequality. The square root of 81 is less than the square root of 89, which is less than the square root of 100. And the reason we can write this is because 81 is less than 89, which is less than 100. Now we can rewrite the square root of 81 as 9, and we can rewrite the square root of 100 as 10. We can now see that the square root of 89 is between 9 and 10. However, 89 is closer to 81 than it is to 100, so the square root of 89 will be a little bit closer to 9 than it is to 10. So let's use this information to find a tenths place decimal between 9 and 10 that multiplies with itself to give us about 89. Let's try 9.4. 4 times 4 is 16, carry the 1. 9 times 4 is 36, plus 1 is 37, add our 0. 9 times 4 is 36, carry the 3. And then 9 times 9 is 81, plus 3 is 84. When we add these together, we're going to end up getting 88.36. Now it's a little bit lower than 89, so we can try out 9.5 times 9.5 and see if it gives us something closer. 5 times 5 is 25, carry the 2. 9 times 5 is 45, plus 2 is 47. Add our 0. 9 times 5 is 45, carry the 4. And then 9 times 9 is 81, plus 4 is 85. Now when we add these together, we end up getting 90.25. So this is 1.25 away from 89, and 88.36 is 0.64 away from 89. So we can see that the 88.36 that comes from the 9.4 times 9.4 is closer to 89. So we can approximate the square root of 89 as about 9.4, since 9.4 squared gives us about 89. This is our tenths place decimal approximation.